Welcome to BS&BEER Canada. I am standing in for our intrepid leader this evening and hosting our slightly more architectural focused version of BS&BEER tonight. So, welcome everybody. I'm really excited about this presentation. Before we introduce our guest speaker, I'm Lori Rand. I am joining you from Halifax, just over my shoulder here. Oh my God, I always do it wrong. Can't do it over there. And I am owner of an architecture firm. I am a building scientist and retrofit advocate. Those are my roles right now. I confess I'm drinking a cup of tea. No beer for me right now. Um, and yeah, I'm gonna hand it over to Connor.
Hey everybody, my name is Connor Malloy. I'm an educator in Toronto. I teach rather, at George Brown Polytechnic. We just went through a name change. So we're a hands-on learning institution. Also do some building consulting for builders and clients building high-performance homes, and do some education as well for professionals through Passos Canada and others. So we're here kind of in the center. Tonight we're drinking Canuck, so it's appropriate Canadian themed beer. And I'm excited for Andy's topic. I struggle with what we're about to talk about today, and I can't wait to learn about new intuitive tools that make it easier for all projects. So, Jeremiah, you're the closest to me. Why don't you take over?
Good evening, everyone. My name is Jeremiah Summer. I'm a builder in Southern Ontario. I also dig building science and like to continue my education on the daily, whether that's in practice, with hands-on construction techniques or theory and research in general. So it keeps me interested and motivated, and I'm also very interested to hear Andy's presentation this evening as well. And I'll shoot it over to Justin.
Good evening, everyone. Justin Ott, owner of Element Construction in Saskatchewan. We are a custom home and renovation company, building science enthusiast, and a building envelope first kind of guy. So, yeah, really looking forward to what Andy's got for us tonight. And yeah, let's get rolling.
Yeah, all right. So, and I'm just excited looking at the participant list. I can see there's a few plants from my team that I can see in here. So, yay, guys. Uh, so, I'm going to introduce Andy Thompson. He is the director at Open Building, which is a nonprofit that is dedicated to high performance architecture. And he describes himself as an architectural climate warrior, entrepreneur, experimental builder, and he's the director at Thompson Architecture. Uh, and so he is here to share the objective tool. I'm going to turn it over to Andy to tell us what he's drinking, first of all, and to talk a little bit more about himself and hopefully give us all a good lesson on energy modeling.
I'm drinking, you can see it's invisible beer. That's pretty cool. It's Bose Love Tread. Um, what uh, what I noticed on the can was a tractor, and I've lived on a few farms and remember farmers teaching me how not to be an idiot, and I've tried to apply that to my practice for many decades. One of the mantras that I learned from a firm in San Francisco was, "What would the farmer do?" And I always think of that when designing roof details, flashing, dormer, building form in general, because farmers, at least the ones I knew, they don't have a lot of time to do things twice. So you want to build it right, get it right the first time, and then you're not having to go back and maintain it. And also being resourceful. So there's a lot of tools out there you can do energy modeling with. Most people can't access them. You need like a PhD to just like load the interface, like text line tools and six modules and a bunch of things. And some connections to SketchUp and then tying it into PHP and whatever else, it can be really intimidating. So our goal was to develop an app that pretty much anyone could use, where you put in the basics you would normally submit when you go for a building permit, like your area, window areas, what's the window wall percentage, stuff that you can measure pretty easily, and just put it all into a web interface. But that's not how the project started. Um, it actually began as an OAA project, and I'm just going to share my screen so I can get my slide deck up. Can you see this? Oh, good. Okay. So the presentation here was UI 3, and I just had to change it to 4 because we're kind of at version 4 now. You can, if you can see the QR code, you can snapshot that for later, or that'll take you to the Excel version of the tool, which is on the Open Building website. If you want to download it from there, you can contribute, you can make a donation, but it's not mandatory. You can type in $0 or 10, and then follow the cart prompts, and that will take you through, and then you'll get an Excel version of the tool. So you already know who I am. The OAA has an awards program. So every 2 years, they have a program called Ontario Association of Architects Design Excellence Awards. And EY reporting has been mandatory now for, I think, 6 or 7 years. So that was the idea behind that was under President Sheena Sharp. And she said, enough about rewarding buildings that look beautiful. It's going to be really important to focus on how they perform. So that Design Excellence Award took on this performance angle, I think 8 years ago, but then the UI reporting was about 6 years ago where it became mandatory. And it's really interesting to see how seriously the judges take it now. So when they get these reports, they're like, well, how can we give someone a gold medal for a building that's got an EUI of 600? And that has really educated the profession at a high level. When you're submitting for OAA awards, you better have a good UI, or your technical adjudicators and your jury in general are not going to take the building seriously. But the problem is a lot of architects out there they may be fantastic architects, have a hard time understanding like just what even does that term mean, like EUI, because we just don't have the tools in regular practice for Part 9 buildings to easily figure out energy and then optimize a building with what we know and then get a reasonable result without hiring a third-party consultant, spending $30,000, 40,000, getting a boatload of reports, and then having it just reflect a kind of a snapshot of your model at a given point in time when design is this evolving thing that you really need to kind of edit and manipulate and massage and kind of work through and get some feedback on how your design's going. So this is what's started happening with OAA awards. The yellow stuff is natural gas in those stack bar graphs. And buildings were coming in well over 300 before the mandating of EY reporting. And then all of a sudden the gas started shrinking out of the buildings. And this is like from 20, I think this is 2022 when we reviewed these buildings. And the buildings all started coming in 100% electric, and then they started going net zero. So zero is the baseline. That's the line on which most of the stack bar graphs are sitting. So that's an energy consuming building. But then when the blue dips down below the zero, those are buildings that are producing more energy than they're consuming. So we started seeing more and more net zero buildings, and that's fantastic. But we also needed, as like reviewers, to have a tool that we could actually go, well, is this bullshit or is it real? So the OAA developed a really simple tool, Cove Tools. They're an energy modeling company based in Atlanta. They got the contract to do it, and all it really did was divide energy by area. So you would put in your utility bills and your conditioned area, and then you would get this little graphic, and that's what the OAA adjudicators used to just, you know, it was a smell test on whether the buildings were actually meeting the EUIs they claimed based on the energy inputs. But it also gave practitioners a tool where they could do this for a Part 9 building where they didn't have an energy model or an energy advisor, or it wasn't meeting like Energuide or Passive House or something else. So the easiest way to do this is just you take your total energy that's on your bills and you divide it by your conditioned area, and then you get an EY. So that's like your miles per gallon. I think most of us probably know this. And then OA member said, well, how do I isolate Teddy from EUI? Because I want to figure out how to do that. And so that's really not easy. And we had this version of the tool called TUI2, which had more and more inputs, but it was getting complicated. And the whole goal of this was it was supposed to be like a nutrition facts label. We just put some basic information, we get a number, and away we go. For us to figure out what Teddy actually means versus what most people think it means, which is envelope losses, we had to do a very deep dive into the building physics and energy modeling calculations and what goes to what path. And by the end of it, we have this beautiful graph that showed us, well, Teddy is really on the energy supply side of the graph. If your blue bar in the middle of this is the building, then everything leaving the building, your energy as it's being lost, is going through the envelope. That's what we call telly to distinguish it from telly. So total envelope load intensity is a more accurate term if you want to talk about a envelope metric, because it includes your thermal bridging and your air leakage heat loss, and then all your regular component heat loss. And the ventilation is something separate. But Teddy is really thermal energy demand, which is how much energy your building heating system needs to provide to make up the difference between everything else, because you've got occupant gains, you've got plug loads and equipment, you've got some standby losses and gains from your hot water system, and then you've got some solar gains, which are usually less than people imagine. And then you're losing all this stuff that's on the right from all the components. Windows lose a lot, floor slab, thermal bridge penalties, and so on. And then unusable gains. That's something we can get into later. But so when we put all this together, we got a tool that really helped us solve this problem. So you've probably seen this butterfly graph before, but it says, in the process of construction or design through construction, your your opportunity for making the greatest changes with the least cost is at the beginning. So we often have our students look at this and go, well, where would you place the dot? Like, when do you want to energy model a building, right? Because where it typically happens is here. You've been through site plan, you've got a basic form, your program set, your budget's worked on, you've got a vision for the design, you've hashed through a bunch of stuff, you've got something, and now you need to bring it to your engineering team for coordination and consulting, and that's when you run the energy model. Except the architecture is pretty much baked at this point. So there's not a huge opportunity to tweak and refine and the siloed approach of architect, consultant, sustainability specialist consultant, blah, 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 all these other people make it difficult unless you're always meeting at the same time. And you can burn through a lot of cash with meetings doing that early. So how do you do an energy model before you even have a building contract, before you even have a contract? Let's say an RFP comes out for a school in Sudbury. We just faced this situation recently. And I worked with Belanger Salak architects in Sudbury to respond to the RFP. But the RFP spelled out you need so many square feet of area for the school. It's going to be a two-story building because of the site constraints. Um, we have this is our aspect ratio. This is where we've got solar access and shade and whatever. And so you can just do a napkin sketch of a building. And if you've got the area, our energy model can kind of fill in the difference. Here's one more slide. I didn't mean to actually present this one. I just wanted to give you the background, but it's a really important one because this is a study from the U.S. Green Building Council. It's a chapter on the East Coast, and they basically put like a line of fit graph, like a linear regression model, and said, how many of these buildings actually line up on the line? And the idea is, if your energy modeling tool is accurate, everything will be on the line. And when they went and they measured, okay, well, here are the design EUIs that the energy modeling program said we should have, and here's what we've measured in the field. It's a complete shotgun scatter plot. Like it's like blah, nothing's almost nothing's on the line. A few of these are, maybe these are good practitioners, or maybe they were lucky, right? But everything should be on the line. And then you look at this other one, and it shows a whole bunch of buildings that fall off. They're not even on the graph. They're using more energy than the building code baseline. So this is what's called the performance gap, and it's a huge problem in the energy modeling world. And a lot of people don't want to talk about it because uh, it can result in lawsuits. If you make any kind of claim that suggests uh, your building should be or is estimated to use X amount of energy, uh, that can be risky legally. Now, is that my hand up because I went like this, or is that a question that somebody has? It's probably just a fluke of Zoom.
That's you. I don't know. It's Zoom being weird.
Okay, I'll just ignore it. My own question. What am I talking about? I don't know anymore. Um, so we cooked up this app, and I won't even show you. Well, I'll show you briefly the Excel. Can you see my Excel here? So it used to be really easy, right? We just had a few lines, and then it got super complicated. And then there's like wall of text and numbers. And this is objective, the Excel version. It's not very friendly, but all you have to focus on are the blue things, right? If you put in what are in the blue fields, which are pretty easy, simple things, and you just follow the blue things all the way to the end, all the black fields calculate for you, so you don't have to get intimidated by all the numbers. Um, the way it works is we've got three lines along the top. The first one is lifetime carbon. That's kind of foreign to Canadians or Americans because it's a European metric. So if you lived in Denmark or Sweden, you're pretty used to this, where this is a roll up of the 50-year service life of a building, all its operational emissions, and all of its embodied carbon emissions divided by 50 years. So that's like your annual carbon allowance for the building. And if a building in Denmark has a higher than 5 lifetime carbon number, it fails to get a building permit. You have to be at 4.8. So that means your embodied carbon footprint in terms of kilograms per square meter has to be under 300. Like no, you can't do a 500 building in Denmark anymore. That's so no concrete shear wall office towers will pass that standard. So the next one is just your standard annual greenhouse gas emissions. So this building right here, this is Evelyn Bouchard's house in Quebec. So it's a passive house on a Quebec grid, 98%, carbon-free grid, which means that's why the GHGI is so low, right? So Evelyn's house, for anyone that doesn't know, I will just show you what it looks like. It's a very pretty little thing in Quebec. Looks like this. So you might have seen this in like different construction media. Taunton Press has published it in Fine Home Building and other kind of places like that. And there's a kind of cross section of the building. So Evelyn was a director of open building. She's now a technical advisor, and she graciously provided us with all of the technical details of her house to run through Objective as a passive house case study. What you're looking at when you see this Excel, that's her house. So if we were to follow the National Building Code Tier 1, that would be the EUI for the building. So she's at 56.3, which is an 88% reduction, just through smarter design. A little bit of a premium on some of the materials and assemblies, but there's almost no mechanical system. It's electric resistance, really, really basic. And they don't have a heat pump because the Quebec hydro is so cheap and clean that there's no real advantage to that. But we could try it with a heat pump. And then the value to the right, you see there's these three columns. That's reference values. So the building code minimum, right? That's always calculating in parallel with everything you're doing. And if you change the area of the building, let's just make this 500 square meters. 500. I can see my reference model's changed, and so has my target design, and so has my actual, because I just made the building bigger, which makes EY lower because my energy inputs didn't change, right? So that's how that works, right? That everything dynamically adapts to whatever cell you edit. So the actual, that's from her utility bills. That's what happens when you put things into this actual column here. So if you have hydro bills and you've got a little bit of wood, she's got a half meter, like a half cord of wood there. And then you can put in oil, gas, and everything else as your inputs from your bills. So that's kind of the most basic component of the original OIA EY calculator was area, conditioned area, and energy bills. And then you get the EY in this actual column. So we have the reference column, which is your building code minimum. If I use the minimum insulation values from whatever code I'm using, and then the target is what our tool is calculating. This is what we think your building will produce. And the actual is the utility bills. So as you can see, when we were designing Objective, Evelyn's house was very carefully calibrated to work our algorithm backwards from utility bills to fine tune it to get to this number for targeting. But we've since then we've had about 50 buildings we've run through this, and every time we kind of calibrate and find ways to make every single one of those 50 buildings line up on that line of fit, so that we've got the greatest accuracy of the tool to real building results versus a method that someone prescribes in some far off city in some place in the world, or says, well, this has been working for 40 years, so we're going to continue using it, like eQuest and Energy Plus and ASHRAE 140 and all of those standards for energy modeling. So the goal for us was we start with reality, we look at what the actual EY is from utility bills, and then we work backwards to derive a method that is a combination of physics, but also stuff that's just in the code. So that's the Excel tool. And when you scroll through, you'll see whatever you change in the sections below. Like if I change my to 300, well, it goes off the chart. Let's make it 30. Okay, so I have more loads because I have more people. So I get more gains. My heating load goes down, but I have a lot more occupant gains, which needs, cooling or more plug loads and lighting loads are really what's driving that UI increase there. But if you make changes, you're always seeing the total at the top update. So that's kind of what we did when we implemented the rest of the stuff. And I won't go over each section because it takes too long to talk about that. We can kind of have a Q&A about that. But there's an occupant load section. There's radiant gains, so things that are gaining energy through the windows. There's transmission losses and then transmission gains. So thermal energy kind of seeping back through your walls in the summertime. There's an envelope and surface metrics stuff, which is all your air leakage and heat loss and door fan testing results and all that. There's a mechanical section, and then your two total sections. One is TEDI and TELI, like I was talking about, envelope and energy demand intensity, and then your EUI totals is the last section, and then I'll feed that back to the top. So enough of this one. I'll get to the fun one. That's this. So if you look at the URI, it's objective.openbuilding.ca. I don't know if you can see this, but objective.openbuilding.ca. That'll take you right there. No login, no payment. It's free. It's open source. This is what you'll see when you first load the app. You'll get this warning that says, don't use this yet, it's under development, which is true. It's pretty accurate, but we're still working some bugs out. So you can close that after you've read it carefully and signed it in blood. And then you get the app. And it's very similar to the way that the Excel app looks and works, right? You've got all these sections you can scroll through. You've got those three lines at the top. I'm just going to move my little controls down here at the bottom. Okay, so then you can see here also what tier I'm on. So the reference tier is always tier 1 per NBC because that's your lowest tier under that scenario. And then your actual building is going to be whatever tier above the National Building Code tier you've got. So are people with me so far? Nodding. Okay, good. So and then you've got a percentage, right? So I'm 48% better than the reference for the greenhouse gas emissions on that line. And then I can see I'm 47% better than the reference on this line. So it's a 53% reduction or 47%, is just the difference. So what happens is I go through here and I can put in what type of building is. There's a help button on the top. So anything I mouse over, it tells me what the item is, which is useful for a lot of things because I might not know what area I'm supposed to put in. So then you mouse over that and it will tell you. But these little flags kind of get in the way after a while, so you can just turn help off, and then those aren't there. There's two ways to look at the interface. I actually, this one's good for printing. It's a big sheet, like you'll have to print it legal sideways or tabloid sideways, but that's a good print view because it gets all of the sheets, the whole app. But when you're working in the tool, it's a little nicer to just, this little arrow in the top will turn it into the tabbed menu. So then you can just tab through these sections to put in your inputs for the building. And then we'll get to the graphs because that's the fun part. That's where you learn everything about how this is working. So if I do the expanded version, you can either collapse all the sections, right? That shuts them all down, or you can pop open a tab at two at a time. So if you want to work between two sections and see the influence between what I change here and what happens down here, you can do that. So that just, I'm gonna go back, expand them all again, and then go to the tab menu. So we built in over 700 climate locations in Canada. These all came from Environment and Climate Change Canada. Abhishek Gower was the guy who provided us with all the data. In the new table that's in the, it will be in the NBC 2025, and it includes future and present weather. So if I took this building, and I'll show you what this building is, right? When you load the app, it already loads a building, and then you can just make changes. And the idea is we didn't want to just have everything be zeros. And then you've got to figure out, well, what do I have to put in and what do I not have to put in? So we loaded a reference, like a baseline building in there. And the building is from Three Feathers Terrace. It's a wedding center. So this is a just over 1,200 square meter A2 wedding center. and the mechanical systems are actually pretty interesting. It's a polished concrete floor, uh, air to water heating system, radiant in-floor cooling and heating off the floor, and then like a de-superheater and a big buffer tank to do all the hot water loads. So super efficient building, like R65 roof, R50 walls, and so on. So for a big A2 building, it's actually pretty efficient. And it has a massive overhang to the south and west for shading. So you can't see it on this elevation, but down over here at the west, there's a big porch, and the idea was for limiting cooling gains in the summer, but also giving people a great place to take pictures if they get a rain out on their wedding day. So that's the building that loads into the interface. What you're looking at is this 93.7. That's coming from the utility bills from the owner that provided those. So those numbers are defaults in here. When you go to the actual versus target energy and carbon, you can just kind of click through and put these values in here. So if I had less energy, let's say 100,000 kilowatts after a year in my bills, then I'll see my actual change, but my model is still at 93.7, right? So I'm just going to reset this. There's a reset button. Just hit factory reset and we'll go back to our original settings. There. So now that's loaded that up. And these little bars, they animate based on what you change. So if I increase the area, for example, of this building, right, I can see that that's reduced my EUI. If I reduce my area, right, and I keep cranking it down, that goes in 1,000-meter intervals. You can see that EUI goes up because you're just changing the denominator. So let me just hit reset again. Okay. So this building in particular is a assembly occupancy, but let's say I just want to do a house. I can just start going through this and changing things. Now, why did the EUI change? Because I changed the occupancy. Because a whole bunch of things change. If you're doing a house, the plug loads change, the occupants change, a whole bunch of stuff changes. So what I would do then is go to my internal gains and I can see, well, I've got 126 people in this building, when in fact, I only have like 4 or 3 maybe in a house. So let's put in 3. Then I go back to my info section and I've got an area, right? So I can go, well, let's make it a 4,000 square foot house. I'll put in 400, right? Now I've got a 4,000 square foot house. And then the reporting year, I'm just going to turn off my help again so those aren't in the way. My reporting year plays a role in the emissions, the carbon emissions. So this house is in Ontario. If I go to climate, I'll see it's in Ontario, Alexandria. So let's put this in Halifax, right? We'll go Newfoundland, Labrador, Nova Scotia. And then we scroll it down to Halifax, and we see my carbon emissions have gone up quite a bit. Like I'm 1974 over the baseline. So I guess because we were looking at an Ontario reference baseline. So in that case, I would have to go back over and adjust my reference and say, well, my reference building is also got to be in Halifax. So I go to show reference. Now it's the same interface, but now I'm looking at the reference model. So my reference model used to be in Ontario, but I'm going to change it now and put it in Nova Scotia and Halifax. Okay, and now I'm only 183% over because it recognizes now the reference building is on the Nova Scotia grid, right? So what do we do from there? So we've got assembly, we've got to change that to residential, so those both match. And then let's pick a residential, like a heat pump standard, C4, that's an OBC thing. So let's go NBC tier 1, and then I'll go back into the target model. So target and reference, is it clear what those two things are? Reference model is the thing you're comparing it to, which is your building code minimum, and then target is the building you're designing. So you're always working with both, and they can have or not have the same or different areas, right? There can be 100% independence between these two models. So if I go back to this and I go, well, I've got to change my area now so that the reference model and the target model both have the same area. And I'm going to say the year is 2025. And when I go back to my target model, I'll adjust that also to 2025. So there's no change in the Nova Scotia grid results based on the reporting year. But if I did this in Ontario, where we have really detailed emissions targeting for every year, my emissions will go up or down based on what year I put in for the reporting. And then my service life, the longer a building, the more durable, or the longer a building is designed to stand around, that will reduce my lifetime carbon because my embodied carbon endures over a longer service life. So that will drag down your embodied carbon. So a library, a fire station, buildings that are more durable, that have bigger budgets, tend to, you can do that, not as a cheat, but they're generally going to be longer lasting buildings. The typical service like we put in is 50 years. And then you can put in the project name, and that will save to the storage. By the way, the way this software works is you're in a web browser, but what happens is the minute you load this app, you've got a local version of the software, just happens to be running in your browser. So there's no transmission to a cloud. We're not scraping data. There's no back and forth. This isn't running on a server. This is running on your local machine. So all the changes you make are writing to your web browser locally using something called local storage. So this all gets remembered, and then you can save the file when you're done with export user data, CSV, and it will save everything you've worked on. So it's got an import function and an export function, just like regular software would. So we're going to set the same standard here. Oh yeah, we decided it's Halifax. We're going to use NBC Tier 1. So let's say I wanted to use Tier 1, and if I look at my transmission losses, I've got U values. These are all custom U values from that wedding center. But what I want to do is load up a scenario where I'm just loading up only the NBC1 Tier 1 code standard. So I go back to info and I go set values. So I selected that. I hit set values. Now when I go back to transmission loads, this is my Tier 1 required minimum insulation levels and my required minimum U values for the windows. They've all loaded up. So that's my building code minimum, and my target model is only slightly different. We'll get into why. So now I've got C residential, NBC Tier 1. I've got my utility bills, 2025, and a 400 square meter area. And then I can look at my reference model and kind of make sure that we're doing the same thing there. So reference, C residential, NBC utility bill self-reported, 2025 and 400. Good. So they match. Now we can look at climate, present and future. Well, let's see what that does. So if I go into the target model, I feel like at this point in presentations, I tend to start losing people. So I'll get to the graphics soon because that's way more fun. But if I wanted to test this for the future, I can see what the difference future weather would have on the model performance. So Halifax, I'm guessing, is going to see less cooling degree days, or rather more cooling degree days, fewer heating degree days. And we can test that by actually looking here. So see this? It says 4,000 in the present. In the future, 3,500. So you're going to lose 500 heating degree days. The cooling is unavailable for Halifax, though. So that means I have to provide that number by visiting something and punching that in. So we have a link here. It'll take you out to the climate atlas where you can zoom in to Halifax. Yeah. Am I in the right country?
You're really close there.
There we go. Okay. So here's my cooling degree days, and I can see my future is 352. My 1976 to 2005 was 276. So I'm just going to go to like 2025 when we hit a reporting year, and this says 144.2. That's this graph here. So I can dial it into any specific year, which is important. The accuracy of your weather files makes a huge difference in the model. So I'm going to put in 144.2 in our app. Let's go here. 144.2. And that is our cooling degree days now. And if I look at my mechanical systems, I've got cooling, no cooling, cooling. So I'm running a cooling model with this building. So that is our climate. We're all set up now. Let's use present because our reference model is using present also. And then target. So I don't have utility bills yet. I can just put in 0. So if I don't have the utility bills, this section zeroes out because I don't know yet what it's going to do. So it's important here to say, well, am I using utility bills or am I just designing? That's back in the first section, this info section. I'm going to go targeted use. So that zeroes out all this and it says, well, it's not applicable because we don't have that data yet. You fill it in later when you get it. So the target has got 0, but based on what I've given the model so far, it's telling me I'm going to consume 141,000 kilowatt hours a year. So let's make some more adjustments. Is this a mass timber building? No, it's probably part 9 stick frame. What am I doing for wind, water, and solar? Do I have any renewables in this building? We'll just say no for now. Then I've got a water section. And instead of user defined, I probably want to say, because I have 3 people, 3 occupants I put in, I'll just use the NBC method, which is the National Building Code. National Building Code says you're going to use 220 liters of total water a day, 88 of which are going to be hot water. That's in the building code. So then I want to kind of jump into my target model, my reference model rather. I'll do that from the global one so it's clear to everyone I'm in reference. And I'm in the water section. I'm going to go and pick the same method, NBC, electric heating system. I can see those same numbers. I'm all good there. I can now come back to the target model, and that's it. So I'm set now for 3 people, 92% efficiency. There's a 0% efficiency drain water heat recovery. Just found a new bug. I'll remember that. 0.42 should have been 42%. And then IAQ, that's your indoor air quality cooling. This is just 45%. You can kind of ignore that. These are just suggested. They're not really connected to the model, but we wanted to have this a place in the software to record if there's a radon problem in the area. We're recording CO2 averaging and TVOC. If you've got a meter or a sensor in the building, you can log that stuff in here. So our occupants, let's make sure we've got the same number of occupants. I suspect this is where this big difference is. See, this says 935 because we've probably got like 126 people in the reference model. So let's go back to the reference. Look at this. Yes, we do. Let's put in 3. Oop, there we go. So now it's lined up. So I can go back to target. 3 people, 12 hours a day is the standard for like HOT 2000. You have two adults, 2 children, 50% of the time. That's sort of the approach. Normal activity level, I've got relaxed, normal, active, and hyperactive, which you might put in if you have like a Lifetime Fitness or something like that. Equipment spec, we'll put in efficient equipment, and that changes your equipment loads typically. So it goes from 5, right? If it's regular stuff that just the building code doesn't expect. But if you make all of your equipment Energy Star certified, best you can get, best lights, pumps, fans, everything else, you get a better result for that. And then if I have elevators or no elevators, elevators actually have a big impact on a project. So that goes into the equipment load line. So then I go to envelope. Let's just go to the graphs because now we've got 2 models and we can improve them from here. So the first graph is the Sankey graph, and that's kind of the most important one where you can see what your building is doing now. And if I look at this, I can show it in the cooling season, and I can show it in the heating season, and I can also show the emissions, right? So they're all scope 1 emissions, scope 2 emissions rather, because it's a 100% electric building that's pulling stuff from the grid. But I can change the mechanical system, and then I'll see a different picture for the Sankey graph. So if I go into mechanical and I switch this from a heat pump to oil, and I say my AFUE is 0.92, and yes, I have my cooling still, and that's my ERV efficiency. Now, if I go back to my Sankey diagram, okay, that's what I had before. I'm going to refresh it now, and my emissions now, I can see I've got scope 1 emissions because I'm burning oil on site. So that's what that's doing. Now, if I go to my water again, and say, well, I'm not using heat pump for the water, I'm using oil. And then I go back to the Sankey, you can see my emissions intensity and my lifetime carbon just jump through the roof. I go back to my Sankey diagram, and now I can just hit refresh Sankey. Now I've got 2 flows of emissions going into the scope 1 emissions. One from my water system and the other from my heating system, right? So you've got scope 2 emissions here and then scope 1 emissions here. And then if I go, let's hide emissions and just look at the Sankey graph, this is now showing me I've got some exhaust loads based on whatever system I provided. So that's my heating system exhaust is going to this cell here. So the name of the game with this whole thing is squashing these little nodes to reduce your losses as much as possible, because that will put downward pressure on your energy supplied side, which makes your building more efficient. So if I go to my mechanical system and I say, well, let's imagine we only had an efficiency in the AFUE of 0.5, right? 50% of my energy is going to go up the flue. Let's go back to the Sankey diagram and look at what the effect of that would be. Now I can see I've got a much bigger flow that's going to my flue. You see what's happening there? So the more efficient the system is, the more heat goes into the building instead of up the chimney. So that's the effect of that. That's what you're seeing there. And then if I hide my emissions again, or rather show my emissions, well, it just increases them. So I'm going to go back to the mechanical systems, and I'm going to put a reasonable, let's say it's a common situation in Halifax for people going from oil to heat pumps, right? So
Yeah, it is.
okay. So obviously, if I go into a heat pump, this is just going to set the building with the minimum NBC tier 1 heating season performance factor, but I've got a slider. So if I just slide this, you can see what a massive effect it has on the building, right? If I pick an HSPF of 10 versus an HSPF of 12, it's like a huge difference in EY. So I cannot underemphasize how important this number is. Get the highest performance heat pump you can, because even if it's more than $1,000 more than the other one, it will save you that money in like 2 or 3 years. That's a no-brainer. So you want to check the reference model. Heat pump is 7.1, and now I can see my target building is doing better than that. So I've got a 50% reduction, not on having improved envelope, but just on having improved the efficiency of that heat pump. And then I can look at my water systems and go, well, how can I make that better? Well, let's get off oil, let's put on a heat pump, and let's give it an efficiency of like 300%, CFP of 3, which is totally reasonable, and put some heat water recovery on that, like 40%, 42. The nameplate ratings of these drain water heat recovery systems, if you don't know what they are, they're very effective. So those are all really good ways to improve the building. And then I can just check my energy and we're good. So now we go to the mechanical system, we've got 14 cooling, and we can improve our heat pump. So let's look at the Sankey again, and then you can study kind of the areas where we could do better now. So the unrecovered ventilation is not bad, even with a 60% heat recovery ventilator. But we've got huge thermal bridge penalties from the floor and the slab, and then we've got some heat loss there. So we can kind of fine tune these things to make a better building. So we've got a slider here for thermal bridge. It's a bulk penalty, which is like a sledgehammer. You're just hitting the whole building with this slider, and the typically buildings where people aren't trying, you're building aggregate U value. So if you make a U value of the whole building, it gets penalized by anywhere from 30 to 70% made worse by thermal bridging. If you're passive house, the best you're going to do is 5%. You're never going to have a thermal bridge free building. There's always going to be fasteners or other little bits and bobs that are transmitting more than the general insulation is. So 5 is as low as you're going to get that. So now if I go back to the Sankey and I hit refresh, watch this thermal bridge penalty, right? That's going to get squashed. So that's gone down. And now I got to focus on, look, I've got floor slab is losing it more than everything else. Why? So then you can go into transmission and go, well, the building code doesn't require much for slab. What if I put an R4 there? Huge jump, right? So then I can go to my Sankey, hit refresh, and I keep fine tuning. So you can keep using the graphics to kind of go through the model and squish, squish, squish like bubble wrap, just popping all these little guys on the right to reduce your total loads there. And then as you reduce those loads in your envelope, picking the easiest things to go for first, then your total cost of mechanical equipment, duct sizing, and a whole bunch of other stuff just goes way down. So now we have a building that's got a decent water system with heat recovery. We've got this going on, which is helping us. This can easily be 80. So our heat recovery efficiency can get, let's see if we can get to 100. What would we have to do to get this building to 100? Volume by schedule. Okay, we're already ventilating at the right rate. We've got some setback. That's all good. Volume. Oh yeah, our air tightness. We could probably do better than 1.3. So if we said, it's not going to be passive house, but we're going to aim for a better measured ACH, then I can put in like 1.0, right? And I can see the effect that has on my EY. Could we do even better? Can you get a 0.6, right? Then you're starting to get closer to your 100. So then we can just kind of go through all the sections and look at, well, what can we do now to make it better? Normal gains. Oh yeah, net usable gains. If we do some more massy kind of things or thermal transfer or thermal storage, then we can increase the amount of usable gains we can apply. So that's a whole other thing we can get into. It doesn't do a whole lot actually. Even if I made this a passive house building, I'm only getting down to 122. So this is the amount of thermal energy that's generated inside the building that I get to keep, right? That I can hang on to, that I'm not losing through envelope or ventilation. So thermal mass can help you with some of that, but thermal storage can help you with that even more. Transmission losses, we've gotten our thermal bridging down. Oh yeah, general insulation improvements, right? We could make this R10. We could make this R6. We could make this, there, we're getting close. We could make that R7 for my floor exposed. walls below grade. I don't have any. The slab, what if I made that 5? Right, so you can see the effect of, this is where you can keep trying things and then determine, well, what would my capital cost for making that better be versus what performance gain it's going to give me. But you start to run into a kind of law of diminishing returns. There's only going to be so many things you can do before you run out and can't get much of a better building. So it's probably a good time to take questions now, because I won't overwhelm you with the dependency graph or some of the other stuff, but the next section we have is this one. You can activate graph, and it shows you what the energy model is made of, like what it's doing. So if you wanted to understand the relationship between all the calculations and how this all works, you can kind of click on any one of these nodes, conditioned area, and it shows you all the things that influence that conditioned area influences, right? It's related to all these intensity figures and a bunch of other stuff. And then what its current value is, there's the 400 that we put in, that was the area of the building. And then I can isolate these by groups. I can say recenter, and then just show me the building information. So that's my little group of stuff that I put in the section 2. The effect of my climate, there's my climate system. And then I can look at my water and domestic hot water. That's this little group of nodes over here. And I can see 2 of these are high performance, or rather high impact nodes. So when one of these little bubbles has glowing red outline around it, it just shows me if I edit this, I'm going to get a big benefit in my overall performance. So these glowing red nodes are there to kind of help you understand, maybe look at these, right? Because if you focus on just these things, force layout, refresh, you can kind of zero in on the red glowy ones and then change their values in the app. So there's my primary heating system. Obviously, that one makes a big difference, right? So that is the dependency graph, which eventually will tie that into how our system is calculating. So I'll probably take a stop here and give us some time for Q&A. When do you go to 8 o'clock, Lori, or?
Yeah, we typically, I mean, if we have like a really excited audience with, more questions than you can handle, we might stay a few minutes later. But it's 9 o'clock for me, so I start to fade. But
Okay.
I'm excited by this stuff, so I think I can hang in there.
Okay. Well, I'll just show you. So we started building a model, and it was just a kind of a bullshit model, like a house in Halifax and whatever. Oh, there's questions probably in the chat, so I'll get to those. But
Yeah.
if I want to import a building like that one I said from Evelyn, I can open up the Excel, like I can read the Excel file. So you can see import, I just browse to the Excel file, I go open, it loads all the values from the Excel, and there's Evelyn's house, right? There's that 56.3, there's this one. And if I look at the Sankey diagram for her house, I just have to hit refresh. We'll see this is her scenario. And her biggest loss is actually her south window, right? Interesting. But that's what you see in a passive house is it starts to become about envelope loads, not about ventilation problems or thermal bridge penalties, air leakage or anything like that, because you've taken care of that with the passive house standard. And then because this is a building in Quebec, when I go show emissions, right, you can see, oops. The funny thing is with this graph, because there's so little greenhouse gas intensity on the scope 2 emissions, it's scaling almost as the same size. That almost never happens. Scaling with the same size as the building loads. So usually this is so much larger than the numbers of your losses and stuff that they're not even the same order of magnitude. And then we can take another big building. This one is in Milton, and it's a community center. I will just go to case study buildings. Whoops. This one here. So this is a huge building with a hockey rink in it, with 2 hockey rinks in it, and a library and a bunch of other stuff. So that's just loaded up. This I can see my I gotta reset things. Hold on. Factory reset. And then I'll import that again because I had the wrong value for the reference building. So I'll go import. I'm gonna pick this guy, open. And you can see the console here shows you what it's doing. Okay, there. So now we've got the right reference model, 838. And if I look at the Sankey diagram for this one, I'll just get anyone to tell me, chime in. When I refresh this, where is my biggest loss? How can I deal with it? Anyone?
With an HRV.
Yeah. Okay. So an A2 assembly building, which is what this is, right? Under the Ontario Building Code SB10 uh, for Zone 5 in 2010 does not require any heat recovery equipment at all on a hockey rink or these other kind of big gathering spaces. So if all I did was put in a 70% heat recovery system in there, and I go back to my Sankey diagram and I hit refresh, that goes away. And look at the massive load. Like that's a no-brainer. That's a really inexpensive piece of equipment to put on a rooftop and just run. So there was you might have seen before there was 4.8% heat recovery. That's because only the library minor occupancy within this major building required heat recovery. So, but you can kind of chip through the losses on your right with all these little component additions to get you from 508, which is the EY of the real building, down to 297. There's a few more things we could do really easily to just tweak this building and make it a million times better. So I'll stop my presentation there. But the last thing I'll tell you is if you want to export the data that I've just changed, I can export this as a CSV. I'm going to save it to my desktop. It saves it with the project name that was in the thing. And I can just hit save and then it'll dump that down on my desktop and I can upload it later. So I don't have to save things to a web or password and username and two-factor authentication, a million things just to use the app. I can just save my file and come back to it later.
Hey, Andy, those files that you imported there, were they just an export of the data that you had in one of the models?
Yeah, so there's 127 user inputs, right? So the things that I've modified, I go in, I can edit area, I can edit my climate, my location, I can edit my volume, I can edit the equipment efficiency, something. Those are all inputs. So when you save an export file, it doesn't save everything. It just saves what your building is, and it's represented by those 126 things. So if I open up, I'll show you what one of the files looks like.
Yeah, because once you import it, it's going to recalculate everything anyway, right?
Yeah,
Yeah.
I'll just open up. Right, exactly. So you don't need to save every setting. You just need to save what the picture of your building was. Oh, that's not a good example. I have a newer one, a new better one.
So when you were doing your reference models, quick question about, because I'm doing a retrofit on our place right now and it's about a third way done. So with the reference model, so do you have, like I noticed you've got building code stuff in there, but if you're going to say, okay, I want to compare something that was built in 1980, Saskatoon, Canada, right? Like, start me off with a kind of a baseline of the reference model. It's gonna be built to these standards, blah blah blah. Like, is that something that you can do there, or?
Yeah, totally. So if you even if you just take a flying guess at the U value or the R value of the wall, right?
Yep.
It's all in RSI. Everything's in metric. We didn't want to make this able to be used by Americans, so no, but it's all metric, and
You're
that's
gonna make me convert, man. I'm old. Come on.
they'll never be able to steal our code because they won't understand it's all in metric. Um, so they're RSI values, but you get a little conversion that shows you what
Yeah.
the the thermal watts per horse turd mile an hour is or whatever it is.
Yeah, yeah, I can do that.
But you put in the RSI of what you think it is. If it's like 2x6 with fiberglass and nothing else, you can enter all that into the reference model manually. Just blip, 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 put it all in and then save it. And you create your reference model first is always the right way to do it.
Yeah.
And if you're doing a renovation, then you can kind of make it better in your target model and you just layer over, well, what additional insulation am I going to add so that my effective R value goes from like R2 to like R10 or something reasonable.
Yeah. Okay. Okay. Sounds reasonable. Thanks.
You're welcome. And I mean, in the reference model too, you can put in 0 for the heat recovery efficiency ventilator. Like if you don't have a system, it's got no heat recovery, so don't worry about it. And then you just put in air leakage that's like a barn, like 5 or 6 or something.
Yeah, because
I was wondering about that. If it was like you don't actually have any ventilation in the building, then if you put the 0 there, then it looks like it's just venting without heat recovery.
Yeah, well, then you would just adjust your air leakage, right? So
Yeah. Okay.
air leakage as ventilation. So your air changes per hour. There's all the new methods that are in the National Building Code. So the NRL 50 metrics are all the standard, but you get the
Yeah.
conversion to ACH 50. And so you can, if you've got an ACH 50 value, you can put that in. Or if you're a door fan nerd and you want to put in the cubic feet per minute rate that the door fan gives you, you can just type that in too. So those are all available in section.
I got all the data from Sunridge anyway because they did the initial review and inspection of the house anyway. So that's kind of a good baseline, at least for at least for doing renovations. If you're going to go and get the analysis done and then do the board door test, you can throw those numbers in there, and then I can kind of compare the heat load values and everything else with what my energy bills actually look like.
There you go. Well, that's key is when you put in those energy bills, right? If you've got the conditioned area, which is the interior, you go to the interior face of your walls, right?
Yeah.
And the underside of your ceiling, you're not measuring the outside volume of the building, right? That's a very important distinction. Put in the conditioned area and your utility bills, and you're going to get an accurate UI, right? Just as your baseline is your the actual column on the right, the far
Yeah.
right, and then you build up your energy model and try and understand the picture of your building that you have, and you can kind of start fleshing it out with, well, I'm pretty sure the windows are doing this, and I'm pretty sure the walls are RSI of whatever, and I'm pretty sure that it's got a very leaky building, so I'll put in an ACH 50 of 5. And when you start to build that picture, you might be at like 70, and your UI of your actual is like 50, just as a number, right? Like maybe it's worse. Let's say your
Yeah.
actual is 300, and your target model is coming in at like 250. It's worth sleuthing because like I said, the app is really accurate. So you just have to kind of be a little bit of a detective and kind of punch in the numbers that make sense. Oh, we do use a lot of water. There's like 4 teenage girls or something. Like then you put in the luxury setting for hot water use, and you might find that, oh, now we're lining up, right? So it's a matter of kind of matching expectations and use with reality, the reality of the energy bills.
Yeah, that's cool. Yes. So how long have you been developing this? I missed the first little bit of the meeting.
Oh,
Did you hear
sorry,
that?
all these questions in the chat. Let me just, sorry.
There are some questions in the chat. I'm wondering if my other hosts want to ask anything before we go full free for all. And there definitely are some audience members who have questions too, though.
I can jump in real quick. Thanks, Larry. Andy, I think the tool is really exciting. I've struggled as a builder, someone who practices building science and bit of a nerd by learning different modeling tools. I have taken PHPP courses and struggled with filling out that giant sheet for our projects. I think what stands out to me is that your system feels a bit more intuitive. You've
I
got
tried to put it all on one page, not 50 tabs.
Yeah, you've got a help tool, which is helpful. The graph, being able to bounce back and forth from a target to actual is really nice. But the fact that you can start with the sheet filled out, I find that's the biggest stumbling block for me with something like
Having
PHP
a
or not.
template. Yeah.
I don't know what to fill out. It never adds up to the total. And you don't have a way of getting a quick result in 10 or 15 minutes without hours of input. And as you mentioned, when you're trying to do a model earlier in the process, design process, the faster you can get to something to sponsor communication and conversation is really effective. So yeah, I think you've got a great product. We're excited to try it out.
Thanks. Good. Yeah, the inputs like geometric. I mean, there's a lot of things in PHP that you can spend hours and hours getting right, and it makes like a 0.0025 difference in your total model. And you're like, why did I just beat myself up doing that? So we've kind of, I wouldn't say we reverse engineered PHP. We
Yeah.
didn't, but we looked at some of its methods and we said, well, we can use this, like the net usable gains under the passive house method. But then there's NRC research that contradicts what passive house does. So we said, well, we need to have the NRC method too. So we kind of have all the methods, like the National Building Code method, the NBC, the PHP, and so on. There was a question in there in the chat I see. Is tier 3 the only option for target? If not, how does one choose other tiers? You don't have to choose the tiers. They're calculated. So the tier of your reference building is always tier 1, the lowest, the worst. And as you move through your target model and make it better and better, your tier rating will go up and up and up as you reduce more energy. So
Yeah, that was my question.
oh, okay, Matthew. Yeah.
Yeah, I misunderstood target. Like for me, target is like this is what we're aiming for. It's not the current state of the design. which is what target is in this.
Yeah, I'll tell you, there's a little bit of a legal issue there because
Yeah,
if you say the design or estimated or any kind of uh, words that suggest that it is other than a target, like that's a legal dagger that I can stab myself with later. So the reason we say it's a target is because we don't know until we got utility bills. Then we know we met our target. The arrow hit the bullseye. So the language we developed in the use of the tool is supposed to guide us mentally that this isn't a real thing. It's an energy model. The real thing
yeah,
is the utility bills and the actuality of the building. So if you can kind of change your headspace just a little bit to kind of understand what our
yeah.
insurance company wants us to do too. And that's like,
Right.
we're not estimating energy use ever. And we can't say
Okay.
that.
Andy, that was a
Thank you.
really I'm sorry, Matthew. That was a really good presentation, and the process looks fairly smooth for somebody who doesn't work on software like this regularly. Once you tried a couple projects and sort of got the hang of it, like how long would it normally take to put together a or develop a model for a single family residential project,
Oh my
for
God, it's
example?
so fast, it's nuts. That's the advantage of it.
Yeah.
It's night and day over any other tool. So we just did like 5 different submissions for CMHC MLI Select financing, and each building took me like literally less than 10 minutes to put together.
Oh, wow.
So working with an engineer on the phone, like what's the HSPF for I need this and I need this and I need this. Do we have drain water heat recovery? No, the client doesn't want to put it in. Well, you're going to bump from a tier 2 to a tier 3 for financing. It's a huge
Right.
advantage to do that. So for $5,000, let's put it in. Okay, let's put it in. So we can go through all that and we're done in literally 10 minutes onto the next building. And
Wow.
and if you've got a building already built up, like a template, kind of what Connor was saying, once you've got a passive house residence, a MURB, a townhouse, a accessory dwelling unit for a backyard, once you've got a kind of portfolio of buildings, you can just load them really quickly as a as a quick hurdle to jump over and then modify that. So it's
Yeah.
way easier to modify something you've already developed than do it all from scratch. So
Yeah. And
it's really fast that way.
yeah, it's really cool. I was playing along as you were going through the presentation, just dabbling with the demo model, and yeah, it is quite intuitive. Cool, thank you.
Good, you're welcome. Oh, here's other questions. Go over the inputs for the most recent tool. When you say building physics, are you speaking about energy balance broadly? Oh, so one of the features of the Sankey diagram is if you've got the app open and you go to the Sankey diagram, you can squash the Sankey diagram into an energy balance diagram. So it is literally the same energy balance diagram you would see in Passive House, except we split Teddy into the ground source or air source for heat pumps, and we add the hot water, and we add cooling, right? So you can see energy balance and cooling, energy balance and heating, and energy balance with the hot water and the drain, because your hot water goes down the drain. It's a form of heat loss if you don't recover it. So that's not in PHPP's energy balance. So if you just hit the energy balance button, you'll get the energy balance there. And in terms of physics, there's a bunch of things that like schedules and plug loads and stuff that come from the building code. So when you pick those different standards like PHPP or building code or OBC or NBC or whatever or NACB, whatever those standards you pick, they're going to set the schedules and plug loads and lighting loads and equipment loads from those various codes. So that's the non-physics part, which comes from this is what the code expects us to put in, and then the physics part is the transmission losses and gains and those kind of building physical equations that are a function of climate and RSI value or heating degree days and cooling degree days and so on through the
Yash, you had multiple questions. Do you want to like come out and ask the other ones while yours is being answered?
Absolutely. Andy, let me tell you, this is probably one of the best dinners I've had in a while. I had this playing in the background as I was eating. Um, I have one more question in regards to um, the energy balance and basically using the physics, I guess, for building physics behind it. So when you ran these models, are they all basically, at the end of the day, a big energy balance equation that runs everything through in the background, or do you have preloaded simulations that you're pulling things off of for a reference?
No, it's a live dynamic model. So
Okay.
the algorithm is that crazy graph I showed you that looked like, colorful popcorn. That's the relationship between all the components. So when you change any one of those nodes, it's kind of reprocessing the whole model based on that little change. So you had another question. Is there a way you can copy your reference building over the target model?
Yes. Yeah, basically.
That is that's a feature that's on the shelf. It's being actively worked on, but we haven't brought it into the hardest thing for us to solve was running parallel calculations between two models at the same time so that every input you change updates all the totals through like 980 calculations. So that's happening every time you change an input, which is really hard to manage without breaking
Yeah.
the system. So we finally got it all working, and it could be better. Our CTO Mark Pavlidis is on this call, so you can pop in and say hi, show your camera if you're not in your jammies already, Mark. But he's working on the dependency graph calculation, so that's the guy to talk to about that stuff. So it will be a graph directed. It's called topological sort. I don't know what it means really, but it's just that instead of running bulk all the calculations at the same time every time a little change happens, the graph model means that if I change a node here, it's only going to update the five things that are connected to it. Right?
Mhm.
So I change this, it only changes these, versus what's happening right now, which is like a sledgehammer. I change one thing and boom, everything has to recalculate. So that's how it's operating now. Open source tool, yes, there is it's an open source tool. There's a GitHub, and if you click on the link at the bottom of the footer, it'll take you over to the repo for the GitHub, I believe. And is there a pro version? There will be a pro version. It's not available yet, but the pro version basically is going to be a finance model. So for the equity finance people that want to know, I want 30% on my money in 3 years. How will you make that happen? We can show them do these things, and you'll get and then they pay us, and our little nonprofit has a survival budget instead of just operating on unicorn farts, which is what we're doing now. If I close the browser without exporting to the CSV, how long do I have before the model vanishes from my browser? If you close your browser, your model's gone. So the browser local storage is saved in the active section of the browser. So if you want to keep your model, you've got to keep your browser open with that tab open with the model. It will stay there. Even if you go to bed and come back the next day, it'll still be there. But if you close that tab, your data's gone. Oof. So you have to save the CSV if you want to save that model. Mark is putting the kids to bed. Okay. And Lori's just clapping forever. Fine.
Matt, did you have another question?
Well, I guess I have a follow-up. So if I haven't saved and I close the browser, does anything pop up and say, "Hey, do you want to save?"
No, that's on you. We expect you to be that smart.
Well, okay. You're gonna
However,
you're gonna catch some people, but they probably won't do it twice.
Well, there's a trade-off between logging in and like
Yeah.
what the tech bros do and privacy, and we opted for 100% privacy, no data transmission. So if you actually load this app in your browser and turn off your Wi-Fi, you can use it for a year, right? You can just continue using it. There's zero data transmission, and that was
Hmm.
our choice. We're not collecting user information, we're not collecting data, we're not scraping data, and people are way more comfortable using the tool and supporting it when we have taken that approach. If they want to
so
continue
I
case studies, they can do that. We publish that information, but that's a
mhm.
tacit disclosure.
Hmm. Hmm.
So
I
it,
used it a little bit the other day, and then I had to restart my computer. And before we got on this call, I went back to it, and it did show some of my changes. So, like, I went through my history. So I think it must remember for a little while,
Exactly. Yeah.
like from the history. So as long as you don't wait too long, I think you're not going to completely lose it.
Well, that's what I was asking. But if we can't, yeah. Anyhow, can't
uh,
count on it, I guess. Or anyhow, it doesn't matter. I know save to CSV, but I because I was playing with it, I noticed it preserved some changes. But so that's why I asked, how long do we have?
Yeah, I think the big thing is when you quit the browser, the local storage is cleared, right? So if you close the tab and you open the tab again, the local storage hasn't cleared because the browser hasn't
Okay.
refreshed itself. So, and different browsers function differently too, like
Mm.
Chrome, Edge, Safari, Firefox, they all do different things.
Yeah.
Do you ever see not a marketplace per se, Andy, but more like a library project references that people would share that you could load where let's say imagine I saw a really great project. I saw Evelyn's house and I don't know her, don't know this project yet, but I can see, okay, that single family looks really close to what I want to build. What does that house, which is a passive certified house in Quebec, what does that look like in my climate zone?
So can
Is
you see my screen right
yeah.
now?
Yeah.
Okay, I'm just on open building. So if I go to shop,
Yeah.
right, and I'll see this load up. Here's my Excel tool, right? So I can go into there and I can make a donation, get the Excel tool if I want. But we also have this thing, objective case studies, right? $0. It doesn't cost anything. So you can go in here and get this, and it's a PDF, and I'll show you what it looks like. So you can just put in your information, your email, whatever, and you'll get a download. The document looks like this, which is kind of like a paint by numbers. So can you see my screen and
Yeah.
the
Yep.
document here? So it gives you a little bit of a blurb about how Objective works. Then it gives you these pages, and the black page on the left represents the target model, and the red page on the right represents the reference model. So if I plug in the same blue inputs, if I zoom in and look at all those things, and I type those all in, I'll get the identical results, right? For the reference and target model. So that's an A2, that's the A2 Wedding Center. And then I go through, there's a Quonset building, a crazy building we built in Ontario. There's Evelyn's Maison du Pré in Quebec. And then we've got the Envisage building on Ottawa Street in Hamilton. So mixed use. Then there's a couple of MURBs in here from Envisage Indwell projects. Dogwood Suites and Simcoe, Embassy Commons in London, Ontario, the Neil Campbell Rowing Center by MGMA. So there's a bunch of really good buildings in here. A net zero house we did in Port Credit called Greenway Residence. And then that big community center I showed you, that was that last project. So those are all in there. And then Evelyn also added Aberdeen House in Hawkesbury, Ontario. So those are all buildings where you can take the
That's cool.
values that are in those and go, these are all good buildings. If I want to end up with a good building that's pretty much close to passive house or would pass passive house,
Yeah.
that's how I can do it. And then you can see a graph at the bottom of this. It shows, um, if I move my thing there, I'm just going to zoom into this. This is what I don't think a lot of people understand is these buildings are all capital cost neutral. They did not cost more to build. Of the 12 buildings that are here, and they've avoided like this one, 47 tons of emissions over its lifetime. So we calculated all this stuff. I move my zoom control so I can see what these totals look. Yeah, $20 million saved across the 12 buildings that we've got listed here in 50-year energy costs, right? These are like massive, significant savings and carbon emission reductions. Total reduction from reference models, the average is 62% by the people that have used the tool to help them get through to a better design. And then we've got our lifetime greenhouse gas emissions reduced is on average 19 tons over 50 years. So phenomenal savings if you just like do the math, and we can do the math with the tool. You can just kind of crunch through everything. But that
Great.
PDF is available on the Open Building site, and we'll also make the PDF, the CSV files for those projects available. So the next version of the case studies, we're aiming to get 50 case studies. So if you've got a building
Yep.
and you want it to be in our 2026 case studies, it's a really nice showcase of your talent and your work, and then it will publish the objective results with it, and then the CSV that goes with it. So if people wanted to, they could click on the link to download that CSV and load it into the file. So all that is in the works.
Very cool.
There was one question about training videos or demos where people could have a bit of a walkthrough if they're learning the tool. Is there anything available that way?
Not yet, but we have a budget to put that together.
Fair.
So
Yeah.
it just we had to kind of finish the tool first, and this group of people here are like the first to see it in Canada, pretty much. Like we haven't even launched it publicly yet. The Excel tool is just the 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 version of the tool that most people know.
Wow.
This web tool is brand new, like this week, brand new.
Wow. Cool.
That's why I said to Lori, let's not talk about my boring architecture jobs. I got this thing. I got to show you this thing.
Yeah.
Hey, Andy, so I just threw a question in the chat there. So how many, I guess, building advisor type companies out here in the Canadian wilderness are people using? Like,
None. And I'll tell you why. So the national or federal government has a very cozy relationship with CHBA.
yeah,
CHBA administers the EnerGuide, Energy Star, and R2000 programs,
yeah,
and the net zero ready houses and all that. Um, they're they train through the provincial counterparts like OHBA and everything else, their own entities like Quality in Ontario to train energy advisors. And so
yeah,
it's kind of a bit of a closed ecosystem. So when we architects and engineers said we're going to develop a tool for regulated professionals to use for design, we reached out to NRCan and NRC and said, well, we'd like to collaborate on this stuff. What should we do? And they said, well, go apply for these grants. So we applied for all these grants, and then we didn't get any of them. They just went to the usual people. And we're like, okay, well, if you want to do something different or better and include more people, let's like open the box a little bit, right? So that's kind of where I'm at on that. So no energy advisors presently are using this, but they can and should be. For example, I'm a subject in an ISO project right now, which is
yeah.
the regulator for electricity in Ontario, to get a heat pump put in at my place. And there's no heat loss done whatsoever. The contractor just waved his thumb in the air and said, we're going to put this in. And I'm like, well, where's your F280? Like heat loss? What are you, like an energy
How do
advisor?
you size this stuff? Yeah, I mean,
Like,
yeah,
how
just
did you size this? I
I
think
know it's like just weigh your hand and
I
magically
know.
the
So
number on it.
I'm getting a 20,000 BTU system for a 5,000 BTU building, and now I'm pushing back and saying, well, let's escalate this because this isn't how it should be done.
Yeah, I've bumped heads with the CHBA and the Saskatoon Home Builders Association and
It
then
hurts your head.
people here. Yeah, I heard a lot actually. Yeah, and you know they were gonna make me jump through so many hoops just to be able to get my project kind of registered with them, so to speak. And I'm like, forget it. Like, why would I go through all that? That's just insane. I
I'm
mean,
in a really bizarre twilight zone with them because I used to be an R2000 program delivery agent and energy
yeah,
advisor under them, but it was before Quality and all those guys started training energy advisors under the NRC certification kind of program, whatever. So I'm still eligible to use Hot 2000 with the EnerGuide module unlock and all that kind of stuff, but I'm not an energy advisor. It's just there's none of us. There needs to be more professionals, engineers, architects, designers, PCINs, builders using and getting into these tools but most of them they're just locked up in a kind of esoteric ecosystem, and I don't quite know why. Because ultimately, me, architect, takes liability for what I do.
yeah,
Enercan doesn't take responsibility for anything, so why do they care?
yeah. Well, yeah, and you know, I got into the kind of the energy sort of biz back in around about 87 and finally gave it up because it was just, I mean, nothing was happening. You
Yeah,
know, just the same old, same old. It's like, really, you're using software from 1980. It's 2025, guys. Like, really? I mean, come on.
yeah, and this is well, we keep so Enercan actually. I don't want to. I'm not beating up on Enercan. They're our friends.
Yeah, yeah,
But they, instead of renovating Hot 2000 and making it better using the current modern software technology, they built a web interface that pushes the buttons of R2000 of Hot 2000 on a server
yeah,
to get it to. So that's their cloud-based version of Hot 2000. It's Hot 2000 running on a 486 PC in a
yeah.
server closet somewhere with a web UI, which is just so crazy to me. But
Yeah.
that's where we're at.
Well, someday they'll get there.
Canada.
Cool.
Gonna change it, hopefully. And
Yes.
the reason we made it free and open source was so we can hopefully aim for the broadest possible uptake, because that'll actually move the needle on performance. I believe that if people have access to accurate software that's fast and easy to use, nobody will have a reason not to use it. You're just going to get a better building if you do this stuff and you build that way. So the goal was get the broadest possible uptake across Canada. It's also why we went to the trouble of putting all the weather files in for Canada. And I got to look at why cooling's not in there for Halifax. It should be.
Yeah. Yeah, that's I guess that because the challenge always has been when I talk to my other work colleagues and such is like, well, can you tell me in 10 minutes or less, how much better my building can be or my new house can be. Nobody has time to time to give you time to actually figure things out, right? So having
Well, the nice thing is
a
with a
tool that's
graph,
easier to use, that's quicker. I mean, then you can start getting some conversations going sooner than later, right?
when you've got a client in the room and you've got that Sankey diagram, you can just show them these are the impacts and the effects of what you're doing. And then you can translate those kilowatts to dollars, which was what the pro version will do.
Yeah.
But when you can show someone they're going to save 75% of their energy costs over not just the first year, but every year for 50 years, like that's a good investment. That's like a really good a return on a stock, except you own the stock, it's your house, right?
Yeah. Have you had any interest from the building appraisal folks?
Not yet. I mean, not a lot of people know about this thing yet. We're getting
Yeah.
there. It's mostly architects and engineers that know about it now.
Yeah, because I was part of a group of developer people that got together and we spun up a development company. We built a passive house designed condominium complex here in Saskatoon. We were done about 2018. Mike Namath was the head mechanical on it and designer. And he does training for Passive House Canada and stuff. But anyway, so one of the issues that we had was for funding was just getting appraisers to actually take a look at the building as designed and give us a value that wasn't kind of market driven, because in the marketplace nobody cares about energy efficiency. Like if you say, well, if I build a building X and it's code today, and I build something like step code 5, which is BC, how much more is it going to be worth when I go to sell it? Well, we don't know.
Yeah. Someone asked a question, what browser is best? I like Safari is really fast if
Yeah.
you're on Mac or if you use Safari, but Chrome has actually got probably the best graphics, and Chrome is the less buggy when you're resetting or clearing or refreshing in terms of cache. So from a software developer's point of view, Chrome is actually pretty good. I kind of use Chrome. I'm using Chrome for this demo now, but it shouldn't matter a whole lot. It's JavaScript running on your local machine, so you can use whatever you like. It's all going to look and feel the same.
Um, I think I want to interrupt this amazing conversation only because I'm fading like a wilting flower over here.
We should
Oh, just
say
as Matt
goodbye.
raises his hand one more time.
Well,
Last question, Matt.
it's a quick one. I'm just looking at the case study document, and I don't. Uh, Forgive me if it's completely obvious. I don't understand the difference between the case study page and the reference page.
They're the same, but the input values are a little different. So if you look at they're the same interface, and that was by design, but the
Hmm.
reference standards have different RSI values for the assemblies, different equipment efficiencies. So if you look in the kind of fine print of the blue cells, you'll see
Yeah,
that that's where the differences are. And so the totals on the black page on the left, right?
yeah.
The red totals, those are coming from those input values. What happened was we ran a workshop and we told people to put in the values from the target sheet, and they did, and then they didn't get the same numbers for the reference because the reference values are all on another worksheet in Excel. So we had to publish both so they could put them both in. So they look the same, but the values are actually different on them. And they might not be different by much, but the differences are there.
Okay, thank you.
Welcome.
So thank you so much.
Thank you.
This is amazing. And if anybody in the next little while asks you if there's any training online and you haven't done it yet, this will be on the BS&BEER. It'll be posted on in a couple of days. We'll have it up so you can point people to us for
Right.
for
And I
the
can
immediate
watch it in
future.
my horror. This is the first time
Yeah, no,
I've demoed
oh,
the interface, so I don't
always.
know how it went.
Everybody, we all think we're incredibly awkward, so it's hard to watch yourself.
Yeah, Eddie, this is a great topic.
Awesome.
Yeah,
Yeah,
Thanks for
excellent,
joining us,
excellent.
everyone.
yeah.
Thanks, Andy.
Feel
Yeah.
free to email. The email's on the website, and
Mhm.
we're happy to kind of address inquiries or whatever you've got if this isn't the forum for it or custom or feature requests or anything else.
I think you'll have a few.
Good. Talk to you later.
Yeah.
Roasting.
Bye, everybody.
Yeah.
Thanks.
Yeah. Thanks,
Good.
guys. See you all
Good night,
next
Thank
everyone.
you.
month. We're,
Bye.
what are we even doing next month? A Christmas show of some sort, I assume.